Hi, hello. I'm back with another concept from stoichiometry, that is calculation of equivalent weights for disproportionation as well as comproportionation reactions. So in this video we are going to see first of all what are disproportionation reactions, and then how do we calculate equivalent weights for them, and then later we'll go for comproportionation reactions and also how do we calculate the equivalent weights. So welcome back to your favorite channel Chemistry with RK. I'm Raghu Kudala, senior teacher in chemistry. I request those who are new to the channel, please do subscribe and then don't forget to click on the bell icon to get a regular update. Yeah, without any delay, let's start our today's discussion. But before that, as usual, I hope you're ready with your pen and books. Okay, so that you can write down all the information I'm going to give you. Okay, yes, so let's start with the definition for disproportionation reaction. Yes, we know oxidation is loss of electrons or increase in oxidation number. A reduction is gain of electrons or decrease in oxidation number. And we know if both oxidation and reduction takes place within a single reaction, such type of reactions are redox reactions. So basically, this disproportionation reactions are also one of the class of redox reactions, which mean you will see both oxidation and reduction within a reaction. But the speciality of this particular disproportionation reactions is we are going to see same element of the same reactant is going to undergo both oxidation and reduction. Normally in redox reactions we see both oxidation and reduction, but you will see that process takes place with individually, right? So that is Zn solid we have, and then Cu plus 2 aqueous suppose, and then this is going to give us Zn plus 2 and aqueous, and then copper is going to convert into solid. Yes, what is the oxidation number of zinc here? 0. And what about this? This is copper plus 2, so it is plus 2 oxidation number. And then zinc plus 2, it is again plus 2 oxidation number, neutral atom, so it is oxidation number is 0. So if you are not aware of how to calculate the oxidation numbers and rules of oxidation numbers, please go back to my video within the stoichiometry. You have in the playlist, so stoichiometry videos mein dekhiye, right? And now this is from 0 to plus 2, you can see increase in oxidation number for zinc, 0 to zinc plus 2, so we can call it as oxidation, right? And then similarly we can see copper plus 2 to copper 0, that is decrease in oxidation number, we can call it as reduction. Yes, so this is a normal redox reaction. Yes, redox reaction. Okay, redox reaction. And now when it comes to disproportionation reaction, the oxidation number of phosphorus is going to come out as plus 1. And then here the oxidation number of phosphorus is going to come out as minus 3, and then here it is plus 3. So how to calculate? Roughly I'll just try to tell you. So 3 hydrogens are there, for each hydrogen plus 1. 1 phosphorus we are trying to calculate for that, so let us take it as x. 2 oxygens, for each oxygen minus 2. So likewise we are going to get x equal to plus 1 for phosphorus in H3PO2. Similarly minus 3, similarly plus 3. Hope you understood. So since it is undergoing from plus 1 to minus 3, it is decrease in oxidation number called as reduction. And then from plus 1 to plus 3, it is increase in oxidation number called as oxidation. What is the difference you observe for the normal redox reaction which I have discussed here, and then this particular reaction? In this also we can see both oxidation and reduction. In the previous one also we can see both oxidation and reduction. But the difference you have to observe here is, in the previous one we can see zinc is undergoing oxidation, copper is undergoing reduction, right? And now if you see here, the same phosphorus is undergoing oxidation and reduction. Now I hope you understood the point. Okay, disproportionation is a class of redox reaction, but we are going to see same element of the same reactant is going to undergo both oxidation and reduction. Hope it is clear. Let me take another example. That is, again, chlorine is undergoing a disproportionation reaction with sodium hydroxide in 2 different conditions. That is cold and dilute condition and then hot and concentrated condition. Okay, this is very famous and very important question for competitive exams actually. Okay, so chlorine, that is Cl2, is going to undergo both oxidation and reduction in both cold and dilute condition, hot and concentrated condition. Okay, yes. So if you observe the oxidation number of chlorine in Cl2, since it is a homonuclear molecule, so it is 0. Okay, and now what about the oxidation number of chlorine here? -1. What about the oxidation number in its +1? Okay, and then so from 0 to -1, it is undergoing reduction. Okay, and then from the same 0 to +1, it is undergoing oxidation. Okay, so this is what we need to. So now the same element of same reactant is undergoing both oxidation and reduction. We can call it as a disproportionation reaction. Similarly, if you observe here, the chlorine's oxidation number is -1 and the chlorine's oxidation number is +5. Okay, so yes, from 0 to -1, again this is reduction. Okay, yes, and then from 0 to +5, so it is oxidation. Okay, hope it is clear. Hope you understood what is exactly disproportionation reaction. Okay, right. So the same element of the same reactant molecule undergoes both oxidation and reduction, then we can call it as what? Disproportionation reaction. Okay, right. So let us just see what is equivalent weight. Like how do we calculate equivalent weight? Okay, so generally equivalent weight is defined as gram molecular weight by N factor. So again, N factor plays crucial role in this calculation of equivalent weights of any compounds. So I request you to go to my previous videos on this solutions. Actually, I have taken this N factors in solutions chapter actually. Yes, I have uploaded that video. You please go back to solutions playlist and then you will see the N factor calculation for acids and bases and salts individually. Okay, right. And similarly, for this disproportionation reaction, how do we calculate the equivalent weight? So disproportionation reaction includes both oxidation and reduction. We know the oxidation is loss of electrons, which is nothing but the N factor for the oxidation reaction. So the N factor for oxidation reaction is the number of electrons lost. Similarly, reduction is gain of electrons. So nothing but the N factor for reduction reaction is the number of electrons gained. So what we are indirectly understanding from this particular concept is, so the number of electrons lost in a reaction, in a particular oxidation reaction, is its N factor. And then similarly, the number of electrons gained in a reduction reaction is its N factor. So overall, like once we know the N factors of individual oxidation and reduction reactions, and then by taking their corresponding gram molecular weights, we are going to get its corresponding equivalent weight. So what I mean to say is, so there is equivalent weight of the entire reaction. Okay, so that is for the disproportionation reaction is going to be equal to equivalent weight in the oxidation reaction and then equivalent weight of reduction reaction. Okay, yes, as I told you already, that is equivalent weight is gram molecular weight by N factor. So particularly for oxidation reaction, it is going to be, if M is the gram molecular weight, we are going to write, so N factor for oxidation reaction is number of electrons lost plus gram molecular weight by number of electrons gained for reduction reaction. Okay, hope you understood. Okay, let me take one example to understand this. Okay, yes, here we have seen one particular reaction. This is what, and now this is +1 to +3, it is oxidation, and then +1 to -3, it is reduction. Okay, and now let us just try to calculate the number of electrons involved in both the reactions. Okay, yes, so from +1 to -3, this is reduction actually, reduction, right? So +1 to -3, reduction. So how many electrons are involved in that particular change? So from +1 to -3, how many electrons need to be gained by that particular species? Okay, so here from +1 to -3, that particular species have to gain 4 electrons. Yes. And then similarly from +1 to +3, how many electrons it has to lose? So it has to lose 2 electrons, right? Hope it is clear. So what I am doing here is, I am just trying to calculate the number of electrons gained in reduction, number of electrons lost in oxidation. So if you see from plus 1 to minus 3, how many electrons are involved? How many electrons change is involved? So from plus 1 to minus 3, it has to gain 4 electrons. Only then this plus 1 becomes minus 3. Hope it is clear. Plus 1 को minus 3 पे लाने के लिए 4 electrons need to be gained. And then similarly from plus 1 to plus 3, so if it loses 2 electrons, then it is going to get plus 1 to plus 3, right? So these are the number of electrons involved. This is in reduction, and then these are the number of electrons involved in oxidation. Okay, so just by applying this particular concept here, that is, yes, equivalent weight, generally we calculate for the species which is undergoing the disproportionation, which is nothing but H3PO2, which can be written as the equivalent weight of oxidation reaction and then equivalent weight of reduction reaction. So let us take its gram molecular weight is m, and then the number of electrons loosed in this particular process is going to be 2 electrons, and then similarly number of electrons gained is nothing but 4 electrons, right? Then finally we are going to get 2m plus m by 4, which is nothing but 3m by 4. This is the equivalent weight of H3PO2 in this disproportionation reaction. In case if they ask the n factor of the overall reaction, and then we are supposed to take, that is m by 4 by 3, right? The same thing we can write it as m by 4 by 3 just by taking this 3 into the denominator. Okay, so this is the overall n factor. Okay, and then there is another way also in generally in different books gives differently to calculate the n factor. Anyway, for to calculate the n factor, you have to obviously define the number of electrons involved in oxidation reaction and also reduction reaction. There is a formula, that is n1 into n2 by n1 plus n2. Yes. So what are n1 and n2 in this particular equation? n1 could be the number of electrons lost in the oxidation reaction, and then n2 could be the number of electrons gained in the reduction reaction. Okay, so if you take, we already know the n1 and n2 values, that is 2 into 4, okay, by 2 plus 4, that is going to be 8 by 6, which will give us 4 by 3. So these two values must match with each other. Yes, okay. In that method we have got 4 by 3 overall n factor. If they ask the equivalent weight, this is the answer. Okay, yes. Hope it is clear. And now if these two values does not match, then we have made somewhere some mistake. Okay, so this is another way to check out whether we have got the right answer or not. Okay, so simply once we calculate this value, just if you take that in the denominator, then we are going to get equivalent weight. This is also possible. Okay, yes, anything is fine. So that's up to you. And then let me just give you one particular example, one more example here. Okay, that is chlorine reacting with NaOH. Let us take hot and a concentrated condition. Okay, this is the equation I have just taken, that is NaCl, and then we will get NaClO3, sodium chloride and sodium chlorate. And then first what we need to do, we need to calculate the oxidation numbers, right? So chlorine oxidation number here, since it is a homonuclear diatomic molecule, the oxidation number of chlorine is 0. Similarly, chlorine oxidation number is -1 in this. Similarly, chlorine oxidation number is +5. And in this particular example, we need to be a bit careful, because here we are calculating the oxidation number for 1 chlorine. So this is the 0 oxidation number for 1 chlorine, right? So what do we take generally? So that is 2x is equals to 0, then x is going to be 0 anyway. But how many chlorines are there? 2 chlorines. But in the products you will see only 1 chlorine in sodium chloride, 1 chlorine in sodium chlorate. So what I mean to say is, so always we need to consider the oxidation number for 2 chlorines. Since left side we have 2 chlorines and right side we have, in each product we have 1 chlorine only. So here for 2 chlorines we have calculated that oxidation number is 0. Similarly, we need to do the oxidation number for 2 chlorines in this one also. So let me just clarify. Okay, it's easy to understand, don't worry about it. Okay, so this is actually what I mean to say is, this is 0 for two chlorines. Yes, you take for one chlorine, you take for two chlorines, it is going to be 0, right? Because it is not in bonding with any other atom, right? So the oxidation number is 0. Here for one chlorine it is -1. So for two chlorines, what is the oxidation number? That is -2. Hope you understood. For one chlorine it is -1, for two chlorines it is -2. For one chlorine it is +5, for two chlorine it is +10. Yes. If you understand this, then everything goes well. Okay, right. So I'm repeating again. Here we have two chlorines, here we have one chlorine only. Here we have two chlorines, here we have one chlorine. So we need to take the oxidation number for two chlorines, not for one chlorine. Since we have two, since we have one, अगर two chlorines को 0 है तो two chlorines को -2 होगा. If we have for two chlorines 0, then for two chlorines it is going to be +10. Clear? Right. And now how many electrons are involved in this reduction reaction? 0 to -2. 2 electrons are involved in this reduction reaction. Okay. And then what about oxidation from 0 to +10? How many electrons are involved? 10 electrons are involved in this oxidation reaction. Yes, simply we can go with the equation, that is equivalent weight of Cl2. Yes, the molecule which undergoes disproportionation reaction. That is equivalent weight of oxidation reaction and equivalent weight of reduction reaction. Okay. Yes, already we have the number of electrons already. So let us take the molecular weight is m, and in oxidation reaction it is 10 electrons, and in reduction reaction it is 2 electrons. So if you just calculate this, you are going to get, that is the LCM will get 10, and then m plus 5m, that is 6m by 10, which will give us 3m by 5. This is the equivalent weight. Hope it is clear. And if you just want to know the n factor, overall n factor for this particular reaction, that's going to be m by 5 by 3. Okay, m by 5 by 3. Hope it is clear. So this is what. And now let us just check. Yes, we have another method to cross check our answer. That is simply we can go with that is n factor. Yes, n factor is equals to n1 into n2 by n1 plus n2, right? Yes, so how many electrons we have got in the oxidation reaction, reduction reaction, plus 10 plus 2. So it is 20 by 12, which will give 5 by 3. So 4 5s are, 4 3s are. So again this number is matching. So obviously we have got the right n factor. Clear to you, right? So this is the overall n factor. If they ask n factor for oxidation reaction, it is going to be 10. And then n factor for a reduction reaction, it is going to be 2. Do you understand? Right. Clear? So how can we say the n factor for oxidation and reduction reactions are 2 and 10? Okay. See here from 0 to 10. So 10 electrons, oxidation 10 electrons, reduction 2 electrons. So they are the n factors for individually oxidation and reduction reactions. But now if you take the overall reaction, that is n factor is going to be 5 by 3. So let me take another example and I will be expecting answers from you. Okay. Yes. You try to do this on your own. That is let me take Cl2, the same sodium hydroxide I am taking, but cold and dilute situation. Okay. Yes. And then what are the products? Yes, NaCl and then NaOCl, sodium chloride, sodium hypochlorite. Yes, I'll be giving you some time. Yes, you try to do it. Pause the video and then try to do it. Yes. Okay, let me just solve, but you try to pause it and then get the answer and then try to check your answer with my answer. Okay. So as usual 0, as usual -1, and here it is +1. Okay. Yes. And now as I told you, 2 chlorines, 1 chlorine. So 0 and then -1. So overall we need to take -2, right? Understood, right? And here for 2 chlorines it is 0, for 1 chlorine it is +1, for 2 chlorines it is +2. Okay, right. And now sir, in this particular reduction, 0 to -2 is reduction. Okay, so this is reduction. Actually how many electrons are involved? 2 electrons. This is oxidation, right? Yes. And then in oxidation also we can see 2 electrons are involved. Okay, right. And now if we just try to take the overall equivalent weight, okay, equivalent weight of Cl2 is going to be the equivalent weight of oxidation reaction and then equivalent weight of reduction reaction, where we are going to take m by 2 plus here also m by 2. So where you are going to get 2m by 2, so it is 1 m by 1. Overall, this is the equivalent weight of Cl2 in this particular. So we know that Cl2 gram molecular weight is 71 by 1, so which is nothing but 71. So equivalent weight of Cl2 in this particular reaction is 71. Hope it is clear. And then let us just cross check our answer whether the overall n factor is differing or it will be same. Okay, n1 into n2 by n1 plus n2, which is 2 into 2 by 2 plus 2, ultimately 4 by 4, ultimately 1. So yes, both the answers are same. Okay, right. Likewise, hope you understood. Likewise, we are going to calculate the what do you say? Equivalent weights for the disproportionation reaction. They may give any type of question. You please go with this particular method. You will get the right answer. Okay, right. And then yes, I have taken already these equations. Yes, this is already explained. And now I want you to comment. Okay, you to comment this particular answer. I'll be leaving this. I'll not be solving this particular question. Okay, just don't worry about the water. Okay, so if you just having any problem, I'll just take out that. Okay, yes. So just try to comment your answers in the comment section. What is the equivalent weight? Okay, equivalent weight, and also overall n factor, and also the n factor involved in oxidation reaction, n factor involved in reduction reaction. You try to comment all these 4 answers. Okay, yes. Just let me just go with yeah. This is also one more question. I have taken several examples. Yes, you just try to solve with this particular example also and try to comment. Okay, so let me just comment for example 2 the answer. You try to comment separately, and then this is let us take example 1. Okay, yes. So these are the 2 examples I am giving you for your homework, and then next let me go with the comproportionation reaction. Okay, so first of all, what is comproportionation reaction? Okay, yes, let us see comproportionation reaction kya hai. This is quite opposite to disproportionation reaction actually. Okay, so disproportionation is one element, that is same element of the same reactant is undergoing both oxidation and reduction. But here comproportionation reaction may, that is the reactions, okay, the reactions in which same element, okay, same element of different reactants, okay, undergoes what? Both, okay, oxidation, okay, oxidation and then reduction. Yes, same thing, just quite opposite. Okay, same element of same reactant is disproportionation, same element of different reactants is comproportionation. Okay, so you will get more clarity once we take example. Okay, that is okay. So here let me take Ag plus 2 plus Ag gives Ag plus. Yes, what is that you observe in this particular example? If you see this Ag plus 2, that is what is oxidation number? Plus 2. And what about the oxidation number? 0. What about the oxidation number? It is plus 1. Okay, so what you observe here is same element, that is silver from different reactant. Yes, this is one reactant, this is another reactant. Okay, undergoing both the reactions, that is oxidation and reduction, to give Ag plus. Okay, so what do you observe here? From plus 2 to plus 1, it is undergoing reduction. Okay, reduction. And then from 0 to plus 1, it is undergoing oxidation. That is same element of different reactants. Same element of different reactants is undergoing both oxidation and reduction. Okay, so such type of reaction is said to be what? Comproportionation reaction. Okay, so let me just give you one more example. That is H2S plus SO2 gives S. So you please try to tell me the oxidation numbers. It is minus 2 here for sulfur, for plus 4 here for sulfur, and then 0. So what do you observe? From minus 2 to 0, it is undergoing oxidation. The oxidation number is increased. So this is oxidation. Okay. And then what about from plus 4 to 0, it is undergoing reduction. The oxidation number is decreased, so it is undergoing reduction. Okay. We can see the same sulfur element, that is same element, sulfur, sulfur, of two different reactants are undergoing both oxidation and reduction. So hence we can call it as comproportionation reactions. So many exams, so many times they have asked which of the following are comproportionation among the given, or which of the following is disproportionation among the given. So they will be giving you four equations in the four options, and you have to select the disproportionation or maybe comproportionation. Just you have to see this particular possibility. Definition में पूरा information है. Okay, so please try to understand that. So minus 2 to 0 oxidation, plus 4 to 0 reduction. Same thing again as how we have done in the case of disproportionation reaction equivalent weight calculation. Same thing here also you have to do. So from here one sulfur is only there, one sulfur, there is no problem. Like the case which I have explained in the chlorine, there we had two chlorines actually. Here one sulfur, happy. So just you can just write down the number of electrons involved in this particular equation. Okay. So here from minus 2 to 0, how many electrons it is gaining actually? So it is just trying to gain 2 electrons. So oxidation में 2 electrons का involvement है, and then reduction में 4 to 0, that is 4 electrons का involvement है. Okay, very important. Hope it is clear. There is no problem in calculating the number of electrons involved, right? And this particular number of electrons involved calculation, and then the approach towards the calculation of number of electrons is useful in the electrochemistry as well. Electrochemistry maybe we have something very important reaction, that is delta G naught is equals to minus NF E naught of cell actually. So this standard Gibbs free energy and standard EMF of the cell calculation may be iska N. What is the meaning of N? N is also number of electrons involved. Okay. Yes. So this particular method approach will help even in this particular calculation as well. Okay, soon we are going to get electrochemistry videos also, don't worry. Okay, yes. And now overall what we can understand here, that is the equivalent weight of sulfur, we can write it as m by, that is number of electrons involved in oxidation plus number of electrons involved in reduction. Okay, so overall what we can write down, that is 2m plus m by 4. Overall we are going to get 3m by 4. This is the equivalent weight. Again as usual we have taken, that is m by 4 by 3. So this is the overall n factor. Same again you can just calculate the same value, that is 4 by 3, by using our same equation, that is n factor is equals to n1 into n2 by n1 plus n2. Yes. So you just take 2 into 4 by 2 plus 4, 8 by 6, which will give us 4 by 3. So 2 4s are 2 3s are. Yes. So these two values are again, yes, they have to match 100%. Okay. So this is what you have to do. And then for the previous example also, let us just try to calculate here itself. Okay. Right. So how many electrons are involved in both the reaction? Let us just try to calculate. So from 0 to plus 1. From 0 to plus 1, here oxidation, how many electrons are involved? 1 electron is involved. And then what about plus 2 to plus 1? Again here also 1 electron only. Okay, there is also 1 electron. So how to calculate? Simply by taking equivalent weight, okay, equivalent weight, okay, of silver. Okay, equivalent weight of silver can be written as equivalent weight of oxidation reaction, equivalent weight of reduction reaction, that is m by 1 plus m by 1, which will give us 2m actually. This is the equivalent weight. This is the equivalent weight, 2m by 1, which is nothing but 2m. Okay. But if they ask what is the n factor, that is the overall n factor involved in this particular reaction. Okay, that is same. Okay, n factor can be calculated by n1 into n2 by n1 plus n2. Okay, right. So what we can write down here, that is 1 into 1 by 1 plus 1, which will give us 1 by 2. Okay, yes, this can also be written as m by 1 by 2. So both the values are matching. So this is what you have to do. Okay, so finally, let me take a very common and very famous example, which is getting frequently in the various exams. Okay. Yes, let me just try to calculate the equivalent weight for this particular equation. Equation is P4 gives PH3 and then H2PO2 minus. So just first of all, please you try to define whether it is comproportionation or disproportionation. And later I want you to calculate the equivalent weight. Students, those who have understood my previous examples, they can easily do this particular example. Okay. Yes. So first let me just calculate the oxidation number of phosphorus 0, and then here in this it is -3, and then here in this +1. To tell me or classify the oxidation and reduction reaction. So from 0 to -3 it is reduction, and then from 0 to +1 it is oxidation. Yes, what do you observe here? Same element, that is phosphorus is undergoing both oxidation and reduction. So what type of reaction it is? Disproportionation or comproportionation? Disproportionation, right? Yes, very good, beautiful. And then next, calculate the equivalent weight. One point we need to be very careful, that is, here we are getting oxidation number 0 for 4 phosphorus, but here -3 for 1 phosphorus and then +1 for 1 phosphorus. So this is similar example for the chlorine example which I have explained. Okay, right. So those who have understood my previous examples can solve this particular example very easily. Okay, you try to be ready with your answer, that is equivalent weight. Okay, yes. But let me just start. You try on your own and then try to compare your answer with my answer. Okay, right. So let me start. Oxidation number for 4 phosphorus is 0, and for 1 phosphorus -3, for 4 phosphorus it is -12, 1 phosphorus +1, 4 phosphorus +4. So now how many electrons are involved in this particular change? That is 12 electrons, and then this is 4 electrons. So here this is oxidation, this is reduction. Okay. Yes, as usual we know that the equivalent weight for the overall reaction, equivalent weight of overall reaction is equals to equivalent weight of oxidation reaction and then equivalent weight of reduction reaction. And then we know that is gram molecular weight by oxidation में 4 electrons का involvement है, reduction में 12 electrons का involvement है, and then just if we take that is 12 and then 3m plus m by 12, which will come out as 4m by 12, and then we are going to get m by 3. Yes, so this is the equivalent weight of phosphorus actually. Okay, and now let me just check that another formula we have, right? Just to try to check whether we have got the correct n factor or not. N1 into N2 by N1 plus N2. This is the equation we have. So that is 12 into 4 by 12 plus 4 actually. Okay, so that is 48 by 16, which will give us 3. So 3 is matching with this n factor. So hence our answer is correct. So this is how you can even check your n factor. So this is a frequent example asking in various exams actually. Okay, so n factor is 3 and then overall equivalent weight is m by 3. So with this I hope you understood all the concepts I have explained in this particular video, that is calculation of equivalent weights and also the n factors. Okay, so hope you understood and hope you liked it. So that's it in this video. We'll come soon with the next video on the next chapters, next concepts. Okay, but please before that I request you, if you are new to the channel, please do subscribe and then don't forget to click on the bell icon. Thank you. Signing off.